Hello, everybody, and welcome to today's vOLTHA TST call. And thanks for joining. And as usual, the call is public and recorded, so please be mindful of the comments you make and information you share during the meeting. First up, I have a point that was in the last few TSTs, but we never got to it. There's a patch from Circuit that adds a delete with prefix method for the KV store in order to provide the deletion of multiple keys in one shot. I would really like people to review this. Looks fine to me, but the folks that have a better knowledge of how the KV store works, Ken, Matteo, David, whoever knows, please do review this and just so we can go ahead, either not merge it or merge it. I would rather not have it sit too much. Any thoughts on this one? Circuit, anything on this?
What's the use case for this? I mean, I understand you're just deleting multiple keys. Just kind of curious where it came into play.
Circuit? Do you also have the corresponding patch? Use it?
Yes, this is just an improvement that's about where we are going to the etcd multiple times to delete all of the related things. So in one shot, it is possible to delete all of the etcd resources.
So like when you're deleting the device, you mean?
Not the device, but the resources, actually.
I guess if you remove an ONU, then you can remove all the flows and the gem ports and the T-cons associated with that ONU. Everything that is prefixed by the ONU ID.
Yes, it's just an example.
Yep. I guess my only concern here is if we start deleting things by trees, which makes perfect sense in a lot of use cases, if down the road someone adds data into that tree that didn't want it deleted, but they'll learn quickly, I suspect.
Also, there are some other Gerrit changes related to this. So after merging this, we can merge the others.
Okay. Then again, please do a review in the next couple of days, and I would like to get it merged by the end of the week. I'll ask also on the vOLTHA channel to final review of this one. Okay. Perfect. Anything else on this one, Circuit?
No.
Okay, thanks. Just an update on the wish list. It has been augmented with assignments of work to each company that is working on something. Just go ahead and take a look at it if you're interested. We still don't have an exact feature list for 2.7. That will come upon us getting a better grasp of the things that are in progress and things that can get done and cannot get done. We'll have that down the road. So next up, I want Theo, if you can, please share your screen and go ahead with the demo of the Helm-based charts to replace kind vOLTHA. Just before you go, Theo, let me just mention that I've used them and they are incredibly good, meaning that they're very simple and actually expose a little bit more details and let you understand a little bit more of what you're doing, and actually enable you to swap components in a much simpler way without, like, mentally without having to tear down vOLTHA all the time, and that will benefit the project a lot, in my opinion. So, Theo, go ahead.
Okay, I'm sharing my screen now. Can you see it?
Yes, we can.
Okay. So basically, I have on the right here the instruction in the README to deploy vOLTHA using the new Helm charts. there are step-by-step instruction of operation that you may need to do once. For example, these steps are required as of now before the patches are merged and the charts published, but won't be required in the future. While this needs to be done one-off when you deploy a brand new cluster. Then you get to the commands to really install vOLTHA. That are basically 3 commands. A first command to install the infrastructure. This is completely optional, depending on whether you want to deploy the infrastructure on top of Kubernetes, like you for sure do for development, or you have the infrastructure somewhere else. But let's get started. Here on the left, I'm connected to my development environment. I'm going to trigger some commands in this window, and I just have a watch on all the Kubernetes pod so that we can see things happening in real time. So I'm just going to install the vOLTHA infrastructure. It's a single chart, it's configurable, and by default, it only contains etcd, Kafka, FreeRadius, ONOS, and the BBSIM Sedis server. Now, all of this is configurable in the chart, and you also have the options to install other components as part of this chart. So if you need to, you can deploy either the Jaeger components under the vOLTHA tracing flag, or Kibana, FluentD, and Elastic Stacks, whether you set efk.enable equal true. So everything can be configured during the installation. And basically what this chart does is deploying all the components, plus it deploys one Kubernetes job. And this job is actually responsible to push the configuration into ONOS. The configuration is defined into the values.yaml of this chart, and you have access to the entire network configuration that now is broken in multiple pieces in kind vOLTHA, as well as to the configuration for the single applications. You can, of course, override this. There is just a minor catch that given this is a huge blob of text, it's much easier to override it using a values file than using the --set option in the launcher. But once you are once you have deployed everything, you expose the ONOS services if you need to, and connect to ONOS, and you'll see that ONOS was configured for you. If you install it by default, it will just pre-populate everything with the correct values so that Sedis is able to fetch the data, and the HCP and Kafka and AAA are configured in the correct way. Moving on, well, in the guide, there are examples on how to deploy with multiple replicas of Kafka, etcd, ONOS, and Atomics, how to expose the ports, how to customize the configuration of ONOS, or set up logging and tracing. So everything should be documented, and everything is working as of now. Then we need to proceed to install a vOLTHA stack. It's again one command that will deploy one vOLTHA core, one OF agent, and the 2 adapters. You'll see that there is some customization that we need to pass to the chart here. Basically, we need to tell the chart what's the name of this particular vOLTHA stack. This is needed to support multiple stacks on the same Kubernetes cluster. And we also need to point this chart to where the vOLTHA infrastructure is. Of course, if you need to point this chart to a different infrastructure that was deployed somewhere else, you'll need a slightly different command. It's not written down in the documentation here, but you can just go in the value file and just look at the different values for the Kafka address and the TCD address and so far and so on.
Uniqueness here for a stack name is based on that parameter, stack name parameter, or is it based on namespace plus that stack name parameter?
So the stack name and the namespace can be different. If that was your
Understood,
question.
but can I have the same stack name in two different namespaces? I think the answer is no, but should we allow that?
I think you can have the same stack name in two different namespaces.
Won't that conflict at the Kafka bus?
Oh, yeah, that's right. Yeah, no, the stack name, well, yeah, Elm won't prevent you to do so, but yeah, it won't work because the topic will be the same on the bus.
So I guess the question is, do we want to make the topic a combination so we can? I don't know, just something to think about.
Yeah, that's something we can definitely do. That's actually a good point. So in that way, we can use basically the Elm validation to make sure that the chart is not duplicated. Let me take a note to this. Okay, so I'll make this change right after the meeting, and I'll push it, but it's just a minor change to concatenate the value in a different way. So I'm going now to install this stack. As you see, the namespace has been created and all the components are being deployed. The last, as for before, we have all the instruction to set up tracing and log correlation, etc., etc. And the last thing I'm gonna do is to install BBSIM. In this particular case, we're going to install BBSIM in the same namespace as the vOLTHA stack. I generally do that so I know which BBSIM is associated with which vOLTHA stack, but that's not mandatory as long as you set the correct address when you configure the device. So the components are still being deployed, but we can start exposing the vOLTHA API port, and we can start interacting with the cluster. For example, listing the adapters. They are not there yet. As we can see, they're still starting. Is there any questions so far?
Do you still maintain the OpenVNU Python version charts, or?
Yes, you can absolutely deploy the OpenVNU Python version of the chart. I can add a section on how to do that, but it's so the only thing that these charts are doing are basically aggregating the existing charts. So if vOLTHA adapter OpenVNU chart is enabled, then that chart will be deployed, and you can use the same flags as of today to control it.
Okay, got it.
I'll also add an example to deploy the Python version.
And one more question: how do you arrange the topic names by looking at the stack name?
Yeah, so as of now, the topic names are defined as so they are defined here, but we override them in the single charts. I made some changes. This is the example for the OpenVNU. The topic names are Okay, no, I'm passing them, overriding them in the value. Okay, they are defined as this stack name underscore
Okay.
arbucol.
But you're thinking about augmenting that with the namespace as well.
Yeah, so David's suggestion was to add
Mhm.
here release dot namespace. In this way, between the namespace and the stack name, this will be unique. Another option is to just use release dot name as that unique in Elm.
Okay.
So I'll make this change and I'll push it. And so meanwhile, we have everything running. The two adapters have been registered. I can make this bigger now. And so I can just go ahead and create a BBSIM device. BBSIM was installed with this release name in the vOLTHA 1 namespace. So you can just create the device and enable it. And if I go and look, the device should be enabled. Okay, what did I do wrong? Oh, okay. Of course, it was installed as BBSIM 10 and not 0. So I'm just going to enable that device. And now we have the one with the wrong address here that is still activating because we can't actually connect it, but the other one was active and reachable and reported the ONU and the MIB was downloaded and everything is working fine. We can move on and program the subscriber, but I think you're all pretty familiar with the process. It was just to demonstrate that the system actually works. So is there any question about this change? Anyone opposed to merge it sometime soon? I think one other thing that is worth mentioning is that these changes won't actually break kind vOLTHA. So there will be definitely a period in which you can go one way or the other. But once these are merged, I will argue that we should not make new changes to kind vOLTHA anymore.
I would argue we should do it now, but that's okay. Are you going to go over, I don't know if the demo's done, are you going to go over changing vOLTCUTL, if you will, or using vOLTCUTL with multiple stacks?
Yeah, that's actually fairly easy. Let me just deploy a second stack. So we have an example here. No, it's easier. So let's install this as vOLTHA 2. In the namespace vOLTHA 2. So we see that this other stack is being deployed, and we now, if we list the adapters, we still get the ones from the first stack. So we see that they are prefixed with the first name. What I can do, so there are two ways to control different stacks. I can either expose multiple vOLTHA API services on different ports and configure vOLTCTL with two different configurations to use the two different stacks. Or I can simply stop the port forward for the first cluster and expose the one for the second cluster. And at this point, automatically vOLTCTL will pick up the default, but the port forwarding is now redirecting to the second cluster. And so we see that only the OpenLT adapter is registered for now. The OpenNU is coming soon, but the topic is now a different one. So I don't have a strong preference one way versus the other. For development, for sure, I think it's quicker to just swap the port forwarding. In a real deployment with multiple stack, I will probably not rely on port forwarding and set up an ingress or some other mechanism to expose the port.
Another way could be we may install install the vOLTHA as a Kubernetes pod. So for each vOLTHA stack, we can have a vOLTHA pod, and each of the vOLTHA pod has its own configuration so that you can access to the related vOLTHA API. I am using in that way.
One thing I'm actually suggesting for vOLTHA is we go the approach that kubectl has gone, where they're using context. So you have one configuration file that can have multiple contexts. vOLTHA's approach it at multiple stacks. And so there'd be a concept of set stack, which you want to use, list the stacks, but that would just be all monitored in essentially configuration file in the local system, much like kubectl does.
And I think another option for vOLTCTL will be to kind of treat the stacks as kubectl does for the namespaces. So something like vOLTCTL device list -- stack vOLTHA1, or
yeah, go look how kubectl's looking at context. I mean, that's exactly how it is. It uses -- context, and you can specify the context, and that tells you in this configuration file which certs to use, which ports to use, that type of stuff.
No, yeah, but once you switch the context, all the commands are against that particular cluster.
Well, there's multiple ways. You can, in kubectl, you can do a -- context on each command, and that sets it temporarily.
Yeah, okay. Yeah.
Or you can set it, use a config use context, and that sets it permanently, kind of sets up the default. So it works both ways.
Yeah, but you cannot do something like this in Kubernetes.
And you don't want to do that. I do
yeah,
not
in a real deployment.
I don't think it makes sense for vOLTHA to be kind of a correlation engine. So I don't think you want to do all context.
Fair enough. Also, once you have 1,000 renews on each stack, you probably don't want to get all of them together anyway. Sounds good. So this is everything I had. I'll make the 2 changes. I mark it down in the README, and I'll upload the patch, and I send out a reminder to the mailing list. So please review it once I'm done with these 2 changes and give a +1. Do we want to set a date to merge these changes?
End of the week, Friday?
After they run all the tests suite on using these.
Well,
so what do you mean by all the test suites?
I mean, we have to have all the robot tests creating their stacks using this mechanism.
Not immediately, because these changes won't actually break kind vOLTHA.
I guess I'm suggesting, do we want to? When are we going to convert the tests over? The test
once these patches are merged, because otherwise the test will have to download the charts, add the dependencies, download the dependencies, package the chart, use the chart. That's a lot of work that won't be needed once the charts are published.
and also, I would give it like maybe 1 or 2 weeks of everybody using them before switching over to the tests, because if there are some small changes and adaptations that need to be made, I would rather them make them before going and updating the robot, the Groovy files and the pipelines and all of that to use this. So I would say, let's merge it as soon as possible. Let's start using it. Let's start finding out things that we don't like or that don't work or things that we can be done better, fix those, and then use it in the tests. That's why I was proposing end of this week, or even better, Thursday. So if Friday something is broken, we may fix it before the weekend.
Sounds good to me.
No? Okay. So I guess Teogo, you have the green light to merge it Thursday evening, your time, if
Yeah, sounds good. I'll make the changes and I'll send out a reminder with the expiration date on the patch.
Yep, sounds good. Thanks.
Thanks. I'll give you back the screen.
Yeah, so it's thanks for the presentation. There's also another patch which is not that urgent, which is to remove kind vOLTHA. To remove vOLTHA ONOS and just install the apps on a vanilla ONOS image. Not for right now. We will maybe schedule a separate TST and separate demo for that from Theo. But do take a look. It's there. So just please do check it out. But priority is given to the one that Matteo just showcased, which is this one. Okay.
One thing I noticed with the apps in netconfig when I was doing the original kind vOLTHA stuff was if some of the apps weren't started or weren't actually up and responding and netconfig was pushed at them, the netconfig didn't take or wasn't actually used.
So
I don't know if that was just in a bug in ONOS at the time or what.
Yeah, that's actually an issue with Karaf itself. It's not the net config that is persisted. Just if the app is not enabled, you won't see it. But the configuration is there. Is the component config, the one that you manage with CFG set org.opencore, the OLT flow manager.
So if I'm not mistaken, what you're doing right now, Theo, is basing the pod that pushes the configuration and the component config on the readiness of the ONOS pod. And the readiness of the ONOS pod has recently changed, well, recently 2.5, vOLTHA 2.5, changed to include readiness of the apps. What that means is that if we follow this chain, you will never push configuration before the app is ready, to answer your question.
No, the job actually doesn't care about ONOS. It just issue commands, and if it fails, it restarts.
Okay, then we should possibly move that pod. Wait for the readiness of ONOS.
So I'm not aware of any way to tell a job to wait for some condition in Kubernetes. But what we can do is to integrate in the script that loads the app the same check that we have in kind vOLTHA, that is basically make sure that the app is active before pushing the corresponding config.
Sure, okay, fine.
But maybe we should also revive the conversation with the ONOS team to figure out why this happened, because this is something that in my opinion is wrong. Like if I configure an application and then I do disable, enable, I should have the same configuration I had before. I shouldn't have to start from scratch for everything. Let me see, I may have a Jira, may not.
Okay.
I'll get back to you.
Okay, let's take that for a separate meeting. But Theo, if there is a Jira, just link it and we're going to talk about it. So next up, I want to have a discussion about a new feature request from Deutsche Telekom, which is MPLS pseudowire, where the OLT gets programmed by vOLTHA to be the endpoint of the pseudowire. And I'll let Amit from Radisys take over with his document and the presentation to give us an overview of the proposal on how to implement this, the requirement and the proposal.
Thanks, Andrea. So I'll take over the sharing.
Yes.
Let me know if you're able to see the screen.
Yes.
Yeah, we can see it.
Yeah, thanks. So this is a doc which I posted yesterday in the vOLTHA TST, vOLTHA Discuss mailing group as well. So for some comments, and we have got at least 1 or 2 comments there. So so this document covers basically the requirements from Deutsche Telekom for the support of MPLS on MPLS pseudo wires on vOLTHA. So I will not go through each and everything in detail, right? But touch upon most of the important things that we would want to discuss right now. But for the other part, you could always go through it after the meeting and post your comments on this itself, and we would get back on those comments. So one important thing that is there in the requirement is that the pseudo wires would be statically provisioned. So there is no dynamic level learning kind of things that are needed. So directly jumping into what this would mean is that, so as of today, the packets that are sent out from the OLT are double tagged, and the packets that come into the OLT on the NNI interface are double tagged. So along with this, there would be 2 MPLS tags that would be added on the packets while going to the switch. So if we look into the packet, so here from frame number 4 or from item number 4 down to the last byte is the packet as is today. So this is the complete Ethernet packet, right? So the destination would be the service edge and the source MAC is of the RG or the CPE. Along with that, the ask is that we encapsulate this entire packet in another Ethernet header with 2 MPLS tags. One of them would be the transport label, the other would be the pseudo wire label. So the outer label would be used to route the packet, the transport label, through the MPLS network, right? And in case of a single hop or penultimate hop, this label could be done away with. And the inner label would be used to uniquely identify the subscriber or the ONT. So this is how the packet would look like as it goes out of on the NNI interface of the OLT. So in the OLT, the downstream packets would be switched based on the outer bit, which is what we have as of today, as well as the pseudo wire label. And in the upstream, the OLT would add the outer bit and the 2 labels, both the pseudo wire label as well as the transport label. And as we just said, that support for label distribution protocol is not needed. The labels would be configured pretty much how the tags are getting configured through. So it would be something integrated with SADIS, where the labels for a particular subscriber would be made available, and it should just use those labels. It is what it says. And the priority bits should be copied over to the EXP bits of the MPLS label. And where it just says that if the OLT inherently has support for DHCP, PPPoE, and those should be transparently forwarded. So we don't need to do anything. That's the same as of today. So looking into this, okay, so the other important thing here is that if you look into this, when we add another Ethernet header or encapsulate the existing packet in an Ethernet header, we need to set the destination and source MAC addresses. So to learn the destination MAC address, the proposal is to use LLDP to learn the MAC addresses of the leaf switch. So there is a app called the VoLTHA topology app, which we upstreamed of late. It's still in review. And this app exchanges LLDP packets with the neighbor. So the OLT or the ONUS app sends LLDP packets through the OLT's NNI port to the leaf, and also expects the leaf to send LLDP packets. And using these LLDPs, it creates a kind of topology as to which port of the OLT is connected to which port of the leaf. So the idea would be that we could use either this app or come up with another simple app if need be to learn the MAC address of the neighbors or the neighbor leaf and use that MAC address to populate the destination MAC. And the source MAC address has to be learned from the device, from the OLT device through vOLTHA. So the app has to be aware of the source MAC address. So yeah, we could go into more details as things become more clear.
Amit?
So yeah, I would take a pause here before we go to the flows. I am sure that we will have a lot of questions.
So the first question I have is the MAC address of the OLT or the switch, is it the MAC address of the interface, or sort of the MAC address, so MAC address of the interface, whether it's the NNI interface or the switch port interface, they could all be different, right? But you can also designate a MAC address for the whole device, right? Think about it as a MAC address that is designated for the OLT and a MAC address that is designated for the upstream switch. And they don't change depending on which interface you go out of, right? So in Trellis, we used to define such a MAC address. We used to call it the router MAC address, okay? So the MAC address of each interface could be different, but you would use this one MAC address to sort of think about it as the MAC address of the loopback port or something like that of the router. So have you thought about this? Is the MAC address dependent on the interface, or do we designate one for the device?
The thought was that we could use the MAC address of the interface because what you just now said, I think would work as long as we have a single interface. But if we have two interfaces lagged onto the same leaf switch, then using one MAC address would confuse the leaf, right?
Well, I mean, depends on what you want to do with that MAC address, right? If all you want to do is discover topology, you can still do that with a single MAC address. If you want to make a decision on whether you want to switch or route a packet, then that single MAC address actually helps a lot, because that's your, in Broadcom terms, it's a my station. It's a my station MAC address, right? So in Trellis, we used to configure this my station MAC address. And that's what would appear in the flow rules. And then if you get a packet with that as the destination MAC address, you choose to make a routing decision. Yeah, go ahead.
Yeah, what I was thinking was, say if we have a scenario where we have two ports of the OLT connected, two NNI ports of the OLT connected to the same leaf switch. and we start sending packets like this, right, with the outer Ethernet header, which has the source MAC of the OLT. Now, if the leaf receives the same source MAC on 2 ports, then won't it be a problem?
No, but Leaf typically doesn't even look at the source MAC of the packet. It looks at the destination MAC. Is the destination MAC my station address, in which case I will route it, or it's not my station address, and in that case I will bridge it. So the source MAC is basically ignored.
Yeah, so if the source MAC is ignored, then yeah, definitely we can use a single MAC address, and I think that would make things simpler than using MAC address of each of the ports. But I think, yeah, that would make much more sense in that case.
Okay, so maybe, okay, something to think about.
Yeah,
that's one thing. The second question I had was regarding the topology app that you're using to send LLDPs. How is that different from sort of the ONOS core facility that also sends out LLDPs for link discovery?
Yeah, so we did discuss, so between myself and Andrea, we were discussing this when we uploaded or upstreamed the app. So some part of the app has an overlap with what is already present in the ONOS core. So specifically the sending of the LLDP packets. So that we could remove from the app and leverage what is already present in ONOS. The other part of the app, which is receiving the LLDP packets from the leaf switch and trying to store it in its own local data structures in the format, right? And then exposing it over a REST interface. That is not really available in ONOS right now. And the app could be trimmed down to have only that part and use the rest from, or leverage the rest from the ONOS core.
Okay.
Yeah, so Surf, the patch is up for review, and I'm working with Amit exactly and precisely for the things you said. The real thing that the app adds is that REST API and internal storage, but it will definitely, in the final version, leverage the existing LLDP sending of ONOS. And actually, it will also leverage the existing LLDP flow installation of the OLT app flow, LLDP flow.
Okay. So Amit, what confuses me, and now I'm going back to the first question I asked. What confuses me is that you called it discovery, right? Discover the MAC address. And I'm trying to see where is the discovery element over here, because assuming you're using the MAC address of each interface as opposed to a single MAC address for the whole device. If you're using the MAC address of each interface, then when ONOS sends out LLDP packets, it does not expect the switch, either it's the OLT or the switch, to actually change the MAC address and put in the source MAC of the interface. It does not expect the switch to do that. It's simply a packet out. Whatever packet you got, shove it out of the interface that I tell you to do it. And so whatever source MAC or dest MAC that you put onto the LLDP packet, the device does not change it. In other words, you actually need to know what MAC addresses you want to put in the source MAC and dest MAC, right? From ONOS, because the switch doesn't change it. So you send it out, and the whole purpose of the topology app, the topology service in ONOS is just to see where it comes back from, right? Not what MAC addresses it has. So you're not discovering anything. The only thing you're discovering is the connectivity. So I sent it out of this port, I got it back from somewhere else. So there's no discovery of MAC address element over here. It's simply a discovery of connectivity.
Yes, that's correct. You precisely summarized
Which,
it
right.
exactly how it is. Okay, and so the topology app is not doing anything with the MAC addresses as of today. So it is discovering which port of the OLT is connected to, or which NNI port of the OLT is connected to which port of the leaf switch. And as of today, there's only support is there only for a single NNI port of the OLT. So it is just finding that.
Right.
What I was saying was that as part of this, it also knows which is the MAC address of the leaf switch from which it got the LLDP packet. And we could use that information.
Yeah, that's fair. But somebody has to put that MAC address in, right? And it's actually
Yeah, so
on
the
us
leaf,
also that puts in.
correct.
The
So
leaf
the
in
leaf
itself
switch
won't do it, right?
no, so when the leaf switch is sending the LLDP packets, it would set its source MAC, right?
Well,
No, not in
again,
a packet out. It doesn't change.
sir, the difference is that in our
Oh,
deployment,
okay.
with the aggregation switch that we, at least the way I understand it, the aggregation switch that we have to send it out to ONOS. When both the aggregation switch and the OLT are controlled by ONOS,
Mhm.
that has to be done. In the DT topology, they don't have the aggregation switch controlled by ONOS. So supposedly, that aggregation switch sends out LLDP packets with the MAC provisioned. Is that the right way of understanding it, Amit?
Okay, I
Yeah,
see.
yeah. That's exactly correct. Yeah.
Okay, so then we have to well check that whatever aggregation switch you're using upstream in the DT case, does it send out LLDP with the source MAC being the interface MAC, or a single MAC address? And usually switches have, you can configure it either way. Usually, like Cisco Arista switches, you can do that. Okay, so now it's clearer to me that it is actually a discovery in that particular case of the MAC address also. Okay.
Yeah.
Good.
So
Thank you.
for the other part, right, when the app is sending out the LLDP towards the switch, in that case, it is exactly how you say it, right? The app itself is filling the source MAC. The destination
Correct.
MAC is, I think, a multicast MAC in that case. But the
Correct.
source MAC, it is sending that and setting that, and it is picking up the MAC address from the NNI port in as is available in ONOS.
Okay, and that packet won't actually come back to ONOS because that switch is not controlled by ONOS. So
yeah, that's correct.
So we will discover in ONOS basically something like unidirectional links. But
yes,
it has to be understood that it's bidirectional. Okay, good.
Yeah.
Well, in theory, probably a small change to the existing link provider through LLDP could be done to check whether if an LLDP comes with a port, we send one out and we can do some correlation and maybe do a bidirectional link, but I don't think it's needed at the moment. It's just a possibility.
It's not necessary. I mean, it depends on how the app wants to process it. I mean, you'll get a unidirectional link, but if the app doesn't care, it doesn't care in this particular circumstance. Okay, that's fine. Please go on.
Okay, so now let's look at the flows. So that is till the extent that we have worked out right now. So, so these are the current flows that are being used, right? So you have this upstream flows, table 0 and table 1. So table 0 is being worked on by the ONU device, and table 1 flow is being worked on by the OLT device, and the opposite in case of downstream. Now, when we wanted to do this addition and removal of MPLS tags, we were not able to satisfy the same using only 2 tables. or 2 flow rules. So we thought we will introduce another flow rule and in another table. And also to do the addition and removal, so the push and pop of this complete Ethernet header, we would have to take help of the open flow extensions. So we have proposed, so right now the name is something like, okay, where is that, push L2 header and pop L2 header. So this extension is something that we would be leveraging from work that was already done in a previous project in ONOS, where layer 2 headers were pushed and popped. So looking at the flow rules, what we are saying is that the ONU, in case of upstream, the ONU flow rule or the table 0 remains as is, nothing changes. The table 1 flow rule also remains as is, but the normal, the existing table 1 flow rule outputs it to the NNI port. So you could say the output is 265536. Instead of that, we will go to another table. And in this table, we will push the layer 2 header along with the MPLS tags. So we will have an MPLS push, right? And another MPLS push to add the 2 tags and add the Ethernet source, Ethernet destination. So using this extension, we can add the header and then output it to the NNI port. Now, similarly, in the downstream, we had the table 0 and table 1 flow rules. We have the table 0 and table 1 flow rules right now. So we will add one more. So the table 0 now would be responsible for getting rid of this, the additional layer 2 header. And then it flows back to the same 2 flow rules that we have. So right now we have 0, 1, they will become 1 and 2. And this table 0 flow rule would take care of removing either if there is a single MPLS header or there are 2 label or there are 2 MPLS labels, it will take care of removing those and then handing it over to the flow rules that we have currently. So at a very high level, that is what the change is. We have not yet worked out the implications of this change on the OLT app as well as vCore, specifically the flow decomposition, the way it would have to start looking at the tables. So that would be our next step to work out those details. But we wanted to share this with everyone and get feedback and thoughts on this.
Flows seem okay to me.
Is everybody okay with the introduction of a third table? Is that something people are opposed? And do people have any thoughts how complex that would be?
I have one fundamental question. Why is it required to put the MPLS support on the OLT switch other than the aggregation switches? I understand DT is not using the trellis. I see that, but isn't it better to have this support on the aggregation side? Because once the vOLTHA supports the MPLS support, and if, let's say, if I want to use the MPLS support, should I still use the aggregation switches via ONOS? If the packets goes out from the OLT encapsulated with the MPLS, probably I need a switch on the aggregation side that understand that's MPLS tags. Is that correct? My understanding correct?
Yeah, your understanding is correct. If it's getting pushed out with labels, then I'll answer your second question first. So it's if the packet is coming out with labels, then it needs to be treated differently in the trellis aggregation switch, just because the first thing that we use to determine whether a packet gets switched or routed or MPLS label switched, that's the first determination that happens. So if a packet is coming with labels, it's going to be treated differently from what it is right now, which is bridging. Right now, it's just VLAN tags, right? So we bridge the packet, but it has to be treated differently once we get labels. But well, that's just a Trellis thing, and so DT is not using it, so it's really just our test infrastructure that would need to treat it differently. As for the first question, which was why, that's the same question I asked, I don't know, a few weeks ago when Manuel was presenting it. And the way I understood it was that, if you look at the DT workflow, they have no control over the CVLAN tag, right? The CVLAN tag is whatever the customer bought from a store, that box, whatever, that's why it's VLAN any. We don't care what that CVLAN tag is in the DT case. So therefore, they differentiate between customers based only on the SVLAN tag, the outer tag, okay? And there aren't enough of them, okay? Which is why they have to introduce MPLS at the OLT itself. So they, at least that's how I understood it, that there aren't enough VLAN tags. And so to differentiate between customers, they need to use labels at the OLT itself. Now,
yes,
if
sir,
I
that's
said that
correct.
wrong, Manuel, yeah,
no, that's exactly to the point. Yeah.
Did that answer your question, Sarkant?
Kind of. So I put a comment here. Does that fits into the SEBA RD, or we reconsider the SEBA RD in this manner?
Well,
so maybe Saraf, if I
yeah, go ahead.
If I try to join at this point. So yeah, I think we are not particularly thinking about the combination with MPLS in a potential fabric network, which could also, of course, and is typically the case, as we said, right? There's Trellis as an open source platform offering those capabilities. So people could think about extending or expanding the fabric switching or routing to the access. But this is not exactly how we would approach it, because this drives complexity into the access. So we are really looking at more keeping this complexity out of the access or away from the access, but ensuring we have the required additional level of encapsulation that allows us to keep those identifiers, let's say, transparent, or just as said, get a level of scalability on top of what the VLAN solutions offer, without bringing in or importing the control plane complexity of a fabric network. So it's in a way bringing in encapsulation on top, but keeping the access as simple as possible from the perspective of the routing and the otherwise, to be considered control planes that you would find in the fabric. I don't know if that helps. So looking at SEBA, architecturally you could take it from a different perspective, thinking from the fabric perspective. But we are thinking it more of like this is just an addition that we can take in the axis without driving the complexity, based on the flexibility we hopefully have with SDN solutions.
I see, Manuel. Thank you.
Is the problem? I have some problems to understand the issue here. So it's the problem that we are trying to solve. Firstly, if we don't use the fabric in the edge, then we put the MPLS tag on the packets to route them in MPLS correctly. This is the first issue. And the second issue is for downstream packets. We are trying to address the correct OLT and ONU. Is it correct? So are there two issues here that we are trying to solve?
So,
Sorry, I lost you there for a second. I had to move to a different part of my house. What were your questions again? Or yeah, if you don't mind repeating. Yeah.
No problem. As far as I understand, there are two problems here that we are trying to solve. I'm DT trying to solve. The first one is to, in case we don't use the fabric in the edge, we need MPLS, say, labels to route the packets in MPLS correctly. So this is the first issue. And the second issue is to address the correct ONU in downstream packets. Is my understanding correct or not?
So we're still using a fabric in the edge, right? Yeah, even DT is, right?
Yes, yes. So I think that might be one solution or one problem you could solve by this, yes, so that you can route within the fabric a pseudo wire to a different edge if you want to. But this is only, I would say, rather a future use case for us right now, which we are not looking primarily at. So we are really looking at primarily solving the scalability, as Saraf has highlighted already, at the link between the OLT to the leaf switch to the fabric. So everything beyond that, which would include routing within the fabric. I mean, I shared some of this when we talked about multi-segment pseudowires in the first presentation. But this is, I would say, rather a secondary use case at this point. So the first issue is really to ramp up the scalability beyond the VLAN label or VLAN text scalability. So in other words, the pseudowires are single hop or single segment, better say, not single hop, single segment, go to the leaf switch from the OLT and vice versa. So I mean, that's just this link initially, but it could be also a multi-hop or multi-segment pseudowire or connection, yes. Not sure if does this answer the question?
Okay, thank you. Thank you, Manuel.
Okay. So I think we can go ahead with the next step, Samit, of analyzing how much would this take within vOLTHA to have those capabilities implemented. It's almost impossible to understand. Surf is very hard to understand you. Can anybody else? Does anybody else have problems?
Yeah, I'm also not able to make out what I was saying.
Okay.
It's calling him from outer space.
I hope he rejoins. I think he was saying something important. Well, I guess I'll get Saurabh's opinion and get back to you, Amit, on the next steps. I think we can go ahead, but I'll make sure that Saurabh was agreeing with me and not disagreeing with me.
Yeah, so I think what Saurabh said was that he is fine with the flow rules. So I think that is the one input that we needed, right? That would be the precursor to the next step. So yeah, anyways, if he has any further comments or if anyone has any further comments, we can always accommodate those.
Sounds good.
Yeah.
Sorry,
Next.
Amit, will this increase the flow counts per service?
Yeah.
Yes.
And is that an optional thing that, or this will be applied to all of the flows or of
No,
all of the
this-
operator workload?
No, so this will be optional only if you have, if you need MPLS packets to be output from the NNI, and if the input is going to be MPLS, then only you turn on this feature, right? Else, if someone is not using MPLS network, then it won't work. So I would suggest that this is optional.
Okay.
Okay, guys, in the interest of time, I would say we wrap it up for today. There was an important topic from Chip that he wanted to discuss. Sorry we didn't get to that, Chip. There was a lot of meat to the fire today. But on the TST meeting agenda, let me take back presentation rights for a second. On the TST meeting agenda, there is information about what Chip wanted to talk about, and he also has a slide as a presentation. So please go through these things before next time. So next time we will have this topic and Chip will do the presentation. And obviously, as all the time, if we arrive informed about the stuff that we're going to talk about, it's going to be a lot more informative for everybody and a lot more helpful for everybody. So please go take a look. And next time we're going to discuss this. I'm going to move it immediately to next week. Just do remember to try out Matteo's patch. If by Thursday we have not heard any comments and things like that, we're going to go ahead and merge it. And if you have any more comments for Amit and the DT team for the MPLS stuff, just go here. I have an action point to follow up with Surf on his last comments. And we'll meet again next week for another TST. Thanks again, everybody, and let's continue great work on Slack and the emails. Cheers, everybody. Bye-bye.
Bye. Thanks. Bye.